Question number 12 asks you to explain how XGAL can be used to determine if a gene is inserted into a plasmid. Right, now, what property must this plasmid have in order for this to work? Well, the property the plasmid has to have is it has to have a gene or region here coding something that's usually abbreviated LAC-Z, which is the gene for beta-galactosidase. Right, so beta-galactosidase is an enzyme that chews up certain sugar molecules. All right, so normally, if we took this plasmid and inserted it into our bacteria as is, beta-galactosidase will be produced. And beta-galactosidase, this enzyme, will take the chemical XGAL and produce a blue color. So if there's beta-galactosidase around, we will get a blue color from these bacterial colonies. Now, so how can we use this to determine if we actually inserted our gene into the plasmid? Well, usually with plasmids that have this LAC-Z gene, there's somewhere in here something called a multiple cloning site, which is where there are lots of restriction enzyme sites. All right, so the multiple cloning site is usually the site where you're trying to insert your gene into a plasmid. So if instead, we had taken this plasmid now, and inside that LAC-Z gene, the YG here, this is your gene. We've now inserted your gene in here. All right, what did this do? Well, it broke up the beta-galactosidase. So as a result now, if your gene is correctly inserted, the XGAL, there's no beta-galactosidase made because the gene for beta-galactosidase is disrupted, which means XGAL can't get converted to that blue color. And so as a result, the colonies are white rather than blue. And so this is how we can use XGAL to determine whether or not we correctly inserted our gene into a plasmid. And the features the plasmid must have, it must have this LAC-Z gene with a multiple cloning site within it.